Have you ever looked up at the night sky? You see all those twinkling stars, don't you? And maybe a planet or two like Venus or Mars. It all looks so grand, so majestic, so natural. But what if it isn't? What if everything you see and everything you don't is not the product of some random cosmic accident? What if our entire universe, with its billions of galaxies and countless stars, is actually an experiment? Imagine for a moment a laboratory. Not one with beakers and Bunsen burners, but something far more advanced. A place where beings of immense intelligence decided to create something truly spectacular. What if they cooked up a baby universe right there in their super advanced lab? This idea sounds like something straight out of a science fiction movie, doesn't it? It's a wild thought, a mind-bending concept, but it's an idea that some very clever scientists have actually considered. They have looked at the numbers. They have studied the laws of physics. And they have asked a very strange question. Could our universe have been made on purpose? It's a hypothesis that pushes the boundaries of what we think we know. It challenges our place in the cosmos. It suggests that we might be living inside something artificial. So let's go on a journey together. A journey into one of the most speculative but fascinating ideas in modern cosmology. We'll explore what a universe even is. We'll look at how we think our own universe got started. And then we'll dive headfirst into this incredible theory. The theory that we are the inhabitants of a lab-grown cosmos. Are we just a tiny part of someone else's grand scientific project? Could the Big Bang have been less of a bang and more of a switch being flipped? The questions are huge, and the answers are even bigger, so strap yourself in. We're about to explore the very nature of reality itself. The implications are staggering, to say the least. If our universe was created by another civilization, it changes everything. It means there's a level of reality above our own, a parent universe from which ours was born. Are our creators watching us? Are they taking notes? Or did they just create the universe, set the physical laws in motion, and then let it run on its own to see what would happen? It's the ultimate nature versus nurture debate on a cosmic scale. This isn't just philosophy. It's a question that some physicists are trying to answer by looking for clues hidden within the fabric of our own reality. Before we can talk about making a universe in a lab, we need to get our heads around what a universe actually is. It's a big word, universe, and it means a big thing. In simple terms, the universe is everything, absolutely everything that exists. All of space, all of time, and everything in it. That includes you, me, the Earth, the Sun, and every single star in every single galaxy. It's the whole shebang, the complete cosmic enchilada. There is, by definition, nothing outside the universe because the universe is the container for all things. It's not expanding into anything. Space itself is expanding. Think of it like a balloon. Imagine you draw lots of little dots on the surface of an uninflated balloon. Each dot is a galaxy. As you blow up the balloon, the dots get further apart from each other. The surface of the balloon is like our three-dimensional space. It's stretching. The galaxies aren't flying through space away from each other. The very space between them is growing. Our universe is this expanding balloon of space-time, filled with matter and energy. And it's been expanding for a very, very long time, about 13.8 billion years to be precise. That's a lot of birthday candles. Now, here's where it gets a little tricky. The universe we can see is called the observable universe. Because light travels at a finite speed, we can only see things whose light has had enough time to reach us since the universe began. It's like being on a ship in the middle of the ocean. You can only see to the horizon, but you know there's more ocean beyond that horizon. The same is true for the cosmos. The universe is almost certainly much, much bigger than the part we can see. It might even be infinite. It's a mind-bogglingly vast stage for the cosmic drama to unfold. So, to recap, the universe is the sum total of all existence. It's all of space-time, matter, and energy. It's governed by a set of rules, which we call the laws of physics. These laws tell us how gravity works, how light travels, and how particles interact. They are the instruction manual for reality. When we talk about creating a universe, we are talking about creating a whole new bubble of space-time, complete with its own matter and energy, and perhaps even its own unique set of physical laws. It's the ultimate act of creation. starting from scratch to build an entire reality. So how did our own universe get started? The best theory we have is called the Big Bang Theory. Now, the name is a little misleading. It wasn't really a bang in the sense of an explosion happening at a specific point in space. It was the beginning of space and time itself. It was the moment that the entire universe, which was once packed into an incredibly hot, dense, and tiny point, began to expand and cool down. This happened about 13.8 billion years ago. It's the starting gun for our cosmic race. Every bit of matter and energy we see today was there at the very beginning. Imagine all the stuff in the entire observable universe, all the galaxies, stars, and planets. Now squeeze it all down. Keep squeezing. Squeeze it smaller than a grain of sand, smaller than an atom. Squeeze it into a point of almost infinite density and temperature. That's what we think the universe was like in the first fraction of a second. Then, for reasons we don't fully understand yet, it started to expand rapidly. This initial super-fast expansion is called inflation. It was an incredible growth spurt that made the universe go from subatomic in size to about the size of a grapefruit in a tiny fraction of a second. After this initial burst of inflation, the expansion continued, but at a more leisurely pace. As the universe expanded, it cooled down. In the first few minutes, it was cool enough for the first building blocks of matter like protons and neutrons to form. A few 100,000 years later, it cooled enough for these to combine and form the first atoms, mostly hydrogen and helium. The universe became transparent. Light could finally travel freely through space. We can still see the afterglow of this moment today. It's called the cosmic microwave background radiation, and it's one of the strongest pieces of evidence for the Big Bang. Over billions of years, gravity did its work. It pulled the hydrogen and helium gas into massive clouds. These clouds collapsed under their own weight, forming the first stars and galaxies. Inside those stars, nuclear fusion cooked up heavier elements like carbon, oxygen, and iron, the stuff we are made of. When these stars died, they exploded, scattering these new elements across space. These elements then formed new stars and planets, including our own Earth. So, in a very real sense, we are all made of stardust. We are the children of the Big Bang, brought to life by the long, slow cosmic dance of matter and energy. The Big Bang Theory is a fantastic description of how the universe began, but it doesn't explain why. What caused the Big Bang? What came before it? Science doesn't have a definitive answer, and it's in this mysterious gap of knowledge that some truly wild ideas can take root. One of the most audacious is the lab universe hypothesis. The idea is that our universe wasn't a random natural event. It was deliberately created by an incredibly advanced technological civilization in a different, older universe. Our entire cosmos could be the result of a laboratory experiment. This idea has been explored by several physicists, but it was brought into the mainstream by people like Dr. Alan Guth, one of the pioneers of cosmic inflation theory, and Japanese physicist Dr. Yasunori Nomura. They looked at the strange conditions needed for the Big Bang. The amount of energy, the specific physical laws, the fine-tuning of cosmic constants. It all seems a bit convenient. The theory suggests that an advanced civilization might have figured out how to manipulate matter and energy at such a fundamental level that they could trigger a new Big Bang. They could create a new expanding bubble of space-time in their lab. Why would they do this? Maybe for the same reasons we do science, out of pure curiosity, to see if they could, to understand the fundamental laws of their own reality by creating a new one and observing it, or perhaps for more practical reasons. Maybe their own universe was growing old and cold and they wanted to create a new, energetic universe to escape into. It's the ultimate survival plan. When your universe is dying, just make a new one. This idea connects the creation of a universe with a purpose, with intelligence, which is a massive leap from the idea of a purely random cosmic origin. The theory rests on the idea that it might actually be possible, under the laws of physics, to create a universe. It's not magic. It would require a level of technology that is completely unimaginable to us today. We're talking about concentrating an immense amount of energy into a tiny space to create a false vacuum, a sort of unstable state of space-time that could blossom into a new universe. It's a concept that comes from our most advanced theories about the cosmos, like string theory and quantum gravity. While it's highly speculative, some scientists believe it's not physically impossible. Our universe could be the successful experiment of a civilization far beyond our comprehension. So, how on Earth, or, well, not on Earth, would you actually create a universe? You can't just mix some chemicals in a beaker and shout abracadabra. The recipe is a bit more complicated than that. According to the physicists who study this idea, the key ingredient is energy, a whole lot of energy, and you need to concentrate it into a very, very small point. We're talking about squeezing the mass of a large asteroid, maybe about 10 kilograms, into a space smaller than a proton. This creates a state of extreme density and energy, something kind of like a tiny artificial black hole. But it's not just about creating a black hole. You need to create a very specific kind. The idea is that you'd create what's called a false vacuum. Think of a ball sitting in a small dip at the top of a big hill. The dip is a stable spot, but it's not the most stable spot, which is at the bottom of the hill. This false vacuum is a similar state for space-time itself, temporarily stable, but with the potential to drop to a much lower energy state. If you could create this tiny region of false vacuum, quantum physics suggests it could spontaneously begin to expand. This expansion would be the process of cosmic inflation, the same superfast growth spurt that our own universe experienced. This expanding bubble of new space-time would essentially pinch off from the parent universe. It would form its own self-contained cosmos with its own dimensions of space and time. From the perspective of the creators in the lab, they might just see a tiny black hole form and then evaporate. They might not even be able to see the new universe they've created. It would be expanding on its own terms, in its own dimensions, completely inaccessible from the outside. They would have lit the fuse for a big bang and then stood back as a whole new reality was born, forever separated from their own. What's truly amazing is that this process might not require an infinite amount of energy. Because of a weird quirk of gravity, the total energy of the universe might actually be zero. How? Well, matter and energy, like stars and galaxies, represent positive energy. But the gravitational field that holds everything together can be thought of as having negative energy. In a flat universe like ours appears to be, the positive energy from all the matter might be perfectly cancelled out by the negative energy from gravity. This means you could, in theory, create a whole universe from almost nothing. A sort of ultimate cosmic free lunch. If we accept just for a moment that our universe was made in a lab, the implications are, well, pretty profound. It would completely reframe our understanding of our existence. For starters, it would mean that we are not the pinnacle of intelligence in the cosmos. Far from it. We would be the creation of a parent civilization so advanced that they can create entire realities. They would be, for all intents and purposes, like gods to us. But this doesn't necessarily mean they are divine beings who interfere in our lives. They could be more like cosmic scientists who set up the experiment and are now just observing the results from a distance. This raises the question, are we the point of the experiment? Did our creators design the universe specifically so that life, and eventually intelligent life, would emerge? This is known as the fine-tuning argument. The laws and constants of our universe seem exquisitely tuned to allow for the existence of stars, planets, and chemistry complex enough for life. If you change the strength of gravity or the charge of an electron by just a tiny amount, the universe would be a sterile, empty place. So, was this fine-tuning deliberate? Were our creators trying to see what kind of life would evolve in the cosmic petri dish they made? Or perhaps we are just a cosmic accident, a byproduct of the experiment. Maybe our creators weren't interested in life at all. Perhaps they were just testing some fundamental principles of quantum gravity or string theory. They created a universe to see if their equations were correct, and the emergence of life on a small, rocky planet orbiting an insignificant star was just an unforeseen and trivial side effect. We could be like a colony of mold growing on a forgotten piece of bread in a lab. The scientist isn't studying the mold, they're studying the bread. For us, our existence is everything. For our creators, it might be nothing at all. And what about our creators themselves? This theory implies a kind of cosmic ancestry. Our universe was born from a parent universe. But what about that parent universe? Was it also created in a lab by an even older, more advanced civilization? This leads to a potentially infinite regress, a cosmic version of Russian nesting dolls with universes within universes, each created by the inhabitants of the one before. We might be just one link in an endless chain of cosmic creation. It's a humbling thought. It suggests that the reality we know is just one level of a much larger and far more complex multi-layered existence. This whole idea leads to a fascinating and honestly slightly terrifying next question. If another civilization could create our universe, could we one day do the same? Could humanity eventually become advanced enough to create a baby universe in one of our own labs? Right now, the answer is a very firm no. We are nowhere near this kind of technology. Creating a universe would require understanding and manipulating physics at a level that is currently pure science fiction for us. We would need to have a complete theory of quantum gravity, a theory of everything, and the technology to put it into practice. The first major hurdle would be energy. As we discussed, you'd need to concentrate the mass of an asteroid into a subatomic space. The amount of energy required is colossal, far beyond anything we can currently generate or control. We would need technology that can manipulate the very fabric of space-time. We're not talking about building bigger particle accelerators, we're talking about a whole new paradigm of physics and engineering. It's a technological leap, as great as the one between throwing a rock and building a starship. We are, at best, cosmic toddlers just learning to walk. But let's imagine humanity survives for another few thousand or even 1,000,000 years. Let's say we don't wipe ourselves out, and our scientific progress continues to accelerate. It's not impossible to think that we might eventually unlock these secrets. We might develop the ability to engineer space-time itself. If we did, the creation of a baby universe could become a realistic technological goal. We could become the parent civilization for a new cosmos. We would be standing on the threshold of becoming creators, just like the beings who may have created our own universe. Why would we do it? The same reasons our hypothetical creators might have had. Perhaps as the ultimate scientific experiment, to probe the deepest laws of nature, or maybe as an act of survival. If our own universe is destined to end, either through heat death or a big crunch, creating a new universe might be the only way to ensure that consciousness, or life itself, continues to exist. We could seed this new universe with the potential for life, passing on the cosmic torch. It's a powerful and awe-inspiring vision of humanity's ultimate potential destiny in the cosmos. The idea of creating a new universe isn't just about scientific curiosity. It could be the ultimate act of self-preservation. Our universe, as grand as it is, will not last forever. The current scientific consensus is that it is heading towards a heat death. Over trillions and trillions of years, all the stars will burn out, all the matter will decay. Black holes will eventually evaporate through Hawking radiation. The universe will become a cold, dark, and empty place, with nothing but a thin soup of stray particles. In this scenario, all life and all consciousness would inevitably come to an end. It's a rather depressing but likely cosmic forecast. Faced with this ultimate deadline, what could a super-advanced civilization do? They could try to huddle around the last dying embers of energy, but that's just delaying the inevitable. The lab universe theory offers a more hopeful, if outrageously ambitious, solution escape. If you can't save your own universe, maybe you can create a new one, a fresh, young, energetic cosmos full of potential. The new universe would be a cosmic lifeboat, a way for life or information to survive the death of its home reality. It's the grandest of all possible escape plans, but how would you make the jump? As we mentioned, the new universe would likely pinch off and become completely inaccessible, so you couldn't just build a spaceship and fly into it. The transfer would have to be more subtle. Perhaps the creators could encode information into the fundamental constants of the new universe. They could embed the genetic code of their civilization into the physics of the baby cosmos, hoping that intelligent life would eventually evolve and be able to decipher it. It would be the ultimate message in a bottle, cast into a cosmic ocean of their own making. This concept gives the act of creation a profound purpose. It transforms it from a mere experiment into a desperate act of passing on a legacy. It would be the final act of a dying civilization, a way of ensuring that the long journey of cosmic evolution doesn't end in a cold, silent void. They wouldn't be creating the universe for themselves, but for whatever might come after. It's a beautiful and honestly, pretty poignant idea. The thought that our own universe might be such a lifeboat carrying the legacy of a long-dead civilization, is a powerful reminder of the cyclical nature of existence, even on a cosmic scale. So did scientists create our universe? The honest answer is we don't know, and we may never know for sure. The lab universe hypothesis is, at this stage, pure speculation. It's a fascinating story that emerges from the edges of our mathematical understanding of the cosmos. There is currently no direct evidence to support it. We haven't found a made-by-Zorp sticker on the side of a quasar, but the lack of evidence doesn't make the question worthless. In fact, it's these kinds of questions that are the lifeblood of science. They push us to think bigger and more creatively. Science isn't just about what we know, it's about what we don't know. It's about standing at the shore of a vast ocean of mystery and not being afraid to imagine what lies beyond the horizon. Theories like the lab-grown universe are exercises for the scientific imagination. They force us to confront the limits of our knowledge and to consider possibilities that seem utterly bizarre. Great breakthroughs often come from someone daring to ask a what-if question that everyone else thinks is silly. What if the Earth isn't the center of the universe? What if time and space are connected? What if our universe isn't the only one? Whether our universe was born from a random quantum fluctuation or from the lab of a hyper-intelligent creator, our place within it remains the same. We are a curious species on a small planet, looking up at the sky and trying to figure it all out. Our drive to understand our origins is one of the most noble things about us. We build giant telescopes and massive particle colliders, all in an effort to piece together the story of the cosmos. We are driven by an insatiable curiosity, a need to know the why and the how of everything. So, the next time you look up at the stars, let your imagination run wild. Think about the 13.8 billion year story that led to that light reaching your eyes. Think about the Big Bang, the birth of stars, and the creation of the elements that make you. And allow yourself to wonder about the even bigger questions. Are we alone? Is this the only universe? And could it all be a grand cosmic experiment? We may not have the answers, but the joy of science is in the quest itself. It's in the endless, wonderful, and deeply human journey of asking questions. Right then,